Hello, everyone. My name is Darwin Sonoy. I'm a partner solutions architect at GitLab Alliances. Today, I want to talk to you about frictionless DevSecOps, how GitLab's authentic, empowered shift left allows us to accelerate DevSecOps maturity and improve developer joy at the same time. So let's dive right in. During the course of our session, we're going to take a look at several factors that build up into a business as usual habit by software developers. As they're building out their software, they consider vulnerabilities to be just another defect. One of the aspects of this is getting inside of the developer's habit loop. There's some very powerful writing on habit loops and how they work. It turns out that in DevSecOps, we already have one of those habit loops, and we can simply stack remediation management inside of that. Context and timing are also crucial. It turns out when you present the opportunity to fix problems with software at the right time, it's very easy to get people to engage. We also want to talk a little bit about how transparent responsibility really motivates. And this is natural to the place in the cycle where GitLab addresses vulnerability remediation. Collaboration and real-time learning are important matters that GitLab handles in process so that developers can keep working and collaborating about challenging situations they might need to resolve with security problems. And then finally, GitLab's only when necessary approvals reduce friction and noise in the entire process because security only needs to get involved when there's truly something that goes out of thresholds. So in many DevSecOps organizations, we see a challenging pattern. GitLab has established that DevOps as a platform is a great way to ensure that your DevOps is clean, consistent, and unified across the organization. But for some reason within DevSecOps, many organizations still start from scratch. So we end up seeing something like this, where a lot of different tooling is linked together, collaboration is manual or out of band. So it's kind of an organic approach to the sec part of DevSecOps. GitLab really feels that you should start from platform. So instead of starting from scratch, we want to start from platform. And GitLab's platform is importantly an extensible platform. Developers really demand that their platforms be capable of extension at various different levels to make sure that they can tailor them to what they need. And GitLab as a platform, as well as its DevSecOps solution, are both extensible in this way. A lot of things in our industry that seem to be new are also old at the same time. So we have something called undifferentiated heavy lifting when we talk about operations. In reality, developers haven't actually been doing undifferentiated coding via platforms for quite some time. I'm going to call this shifting architecture left because what it does is bring entire architectural patterns further to the left of the process so that when we work with these systems, we're able to look at them as entire systems instead of pieces and parts. So let's take an example. If we look at something like the Ruby programming language, it is a very rich programming language. It allows us to do a lot of things. But anytime we have a computing language, developers quickly start to collaborate because they notice they're rewriting the same code as people in other organizations or in their same organization. And so within Ruby, like many languages, we have a dependency manager with shared code libraries. In Ruby, this is called Ruby Gems. And this allows us to consume code that others have written, tested, and continue to maintain that we can just depend on so that we don't have to keep writing code for the same things again and again across projects and across organizations. In the case of Ruby 2, we have another layer of platforming or frameworking, which is Ruby on Rails, an application framework. This takes care of even broader based concerns about how to do an application or any given part of it. So let's say that we have an application and we realize that we need to have some database storage to persist certain attributes of the information. Developers who are working from platform go to the top or most abstract level, or what we might call the leftmost level, in order to understand, is there something here already? So if they find that in Ruby on Rails, they have a complete database management set of libraries and code that manage a lot of extraneous concerns that they may or may not be already familiar with a certain database, well, then they tend to choose that and move forward. If that particular level does not have something in it for them, then they would look to Ruby Gems to see if there's some sort of packaged code that does something similar to what they need to do and is good enough. If Ruby gems aren't satisfactory, well, then of course they're going to have to code something up in the Ruby language similar to their standard application code. And if they're thinking forward toward platforming, they might actually code those as Ruby gems so that they're immediately reusable, versionable, and have all the benefits of dependency management that any other gems that they consume have. So this kind of approach to coming from the top down, the most abstract level, to find functionality that might work is something developers are very familiar with. Now, Amazon has taught the world that this is also possible in operations. So, their cloud infrastructure capabilities, application as a service, and their application building as a service are all examples of a similar abstraction. And when we come into Amazon, it generally is best for us to think in terms of what's the highest level abstraction that can get the job done for me, because it once again offloads that undifferentiated coding. GitLab is showing the world that this is also possible with the DevSecOps tooling that links together all of these pieces into a framework that allows you to be able to manage undifferentiated coding in the best possible way. Within GitLab, we also have an intelligent CI/CD framework, which functions similarly for the concept of CI/CD. So we're really putting platforms inside of platforms wherever we can. It's important to note that these are extensible platforms. So all of these platforms allow you to, at various levels, intervene with a minimal possible code to make them work as you need them to. They're not simply some sort of closed system where if what you have doesn't fit the opinionation of a given part, well, then you're out of luck. They're all extensible. And so this is really a shifting of architecture left by starting at that most abstract level. And one of the interesting things is this scales better with customers' business success. So when we're building an application that we hope to take the market by storm, when we choose platform first development, we're really choosing not only something that gets us more productive more quickly, but frequently is very scalable compared to something we might start building from scratch on our own. Let's take a bit of a dive into why extensible platforms give a lot of power. So, it's very typical for developers to start with some small custom nuggets of code and then over time build a large custom code base. Now, for the actual application that you're creating that's customer facing, this is perfect. We really want to start small, build on that success, and grow it into something that the customer finds valuable. The challenge is that when we do this for something where we can adopt a platform first, it largely ends up being distracting over engineering of something that we do not need to code ourselves. So, a platform first approach means that we look at the platforms we have available to us and try to understand if it has the capability that we need, and we use that if it does. Then, over time, if necessary and when necessary, we make minimal custom extensions to that platform in order to facilitate things that it doesn't currently facilitate directly. So, this is sort of a lean engineering approach where we put platforming first and we make sure that we take advantage of the platforms that we have available to us. So, in the area of DevOps, GitLab really feels that this is the way that you want to approach this, is to do platform first. So I wanted to talk a little bit about platform first because it's such a large part of how GitLab solves the DevSecOps problem. So recently, there's been a lot of excitement about habits. Some really good books have been written, and it's very evident that when humans make small tweaks to their daily routines, it can make very big effects in their lives over time. And this actual effect isn't just true of how we do our personal habits, it's also true of what happens in our work and in business. And so we want to take a little look at how GitLab aligns with the power of human habit psychology in order to bring this effect into the area of vulnerability remediation management. We want to talk about how at GitLab we do an empowered shift left. This means that we shift a very strategic set of capabilities left to ensure that the people who are involved in remediating vulnerabilities have everything they need at the right time. Within GitLab, the idea of shift left includes having direct and clear responsibility for what's going on. When a developer is looking at their merge request, that is only for code that they've changed. So if a vulnerability appears that's new and wasn't there before, they know that they have actually introduced that vulnerability. And this is clear across the entire system because it's their commit, their merge request, and their branch that's being worked on. So that responsibility is early, clear, and easy to identify for everyone, including the developer. Studies have shown that developers are very interested in generating high quality, very secure code. They don't want to be that person that causes some sort of vulnerability in the system. There's also the factor of timing. As we talk here, I'm going to show you how we have the right timing when developers can consider fairly substantial changes to software without a lot of impact to their process. Then having the right tools at that time is also critical. And GitLab allows a lot of additional tooling, training at this time. So GitLab has some just-in-time or on-demand training for given vulnerabilities that's very specific to that vulnerability. So if developers want to grow their capability to understand that vulnerability, well, then they can dive right in and learn about it. And there's even some gamification in some of the training providers. Collaboration, super important. We all know that collaboration is important, but when we start trying to collaborate in 2, 3, 4, 5 different systems, it starts to become unmanageable. If you've ever had vulnerabilities being shared in spreadsheets and emails and documents, it ends up being quite a mess just getting on the same page. So within this context, GitLab allows its full collaborative capabilities to be extended into remediating vulnerabilities. And then, of course, approvals. So while we want to fully empower the developer, we want to make sure that the right approvals are in place so that code that goes out meets the company's quality standards and approvals and security standards, all of the things that need to be met. So when we bring all of these things left, we have a much better picture. If we take a look at typically how this happens, we have an assembled, ready to go product. And then developers are told about the problems that we have potentially from a security perspective. At this point, there's many presenting problems and many people and teams involved. So diffuse responsibility, lots of challenges, lots of desire not to take this apart, swap out some parts, and then redo all the testing to see if it's going to work again. The challenge with presenting this capability of the security scanning at this time is that it compounded from a situation that was not only natural, but much easier to address this problem. So if you think about the time when a developer is working on individual functionality, frequently this is done by an individual person who's collaborating with their peers. If at this point we point out that something's faulty that has been introduced to the system, well, it's not too big of a deal to swap it out because we're still in the mix of trying to get the functionality working. So if making something more tight on security breaks something functionally, well, we have time in order to dig through that and to fix it up. So on the right side, we have kind of what I call the big ball of mud context. And on the left side, we have a very pinpointed responsibility with good timing. We still do need that traditional type of scanning, as we'll talk about in a minute. But if it's our only type of scanning, then we run into this late problem. This also affects developers' literal daily happiness at work, because when you have these problems discovered late, it's very stressful. Usually the deadlines are not moved, and if something has to change, it starts to eat into the developer's quality of life. So this is a good win-win situation for everyone all around. Let's talk a little bit about human habit psychology and how GitLab is taking advantage of some of the new ideas and new discoveries in human habit psychology. Some of this is discussed in the book Atomic Habits by James Clear. First, we're going to just go through kind of what a habit destroying situation looks like. Turns out the same things that you would do to never build a habit are exactly the same things you do if you have a bad habit you want to destroy or tear down. So let's take a look at how habits don't form. So generally habits have a reminder of some type that causes us to be aware of a routine that needs to be triggered. Well, when we make this invisible, this is a sure way to break down an existing habit or to make sure a habit never forms. And so when we have vulnerability remediation management, having a separated scan that's out of process for developers is a great way to make this invisible. As we move along the habit loop, we come to the routine. So routines are what we do when the habit reminder or contextual cue or alarm clock goes off. And if we make sure the engagement is difficult, then a habit won't form or it can be destroyed. And this is very akin to how some of our vulnerability remediation management works when there's out of context consoles, hard communication, unclear responsibility, all these kind of things that happen late, all cause that routine of engaging in vulnerability remediation management to be very difficult for any person. Then, as the routine is completed, it's important with habit loops to have some sort of reward. And it's very typical for these kind of things to be unsatisfying in the case of traditional remediation management. So, all of these aspects an invisible cue, difficult engagement, and an unsatisfying reward all cause a habit to never form, and in fact, can be used to dismantle a habit. Let's take a look at the positive loop and then how GitLab takes advantage of this existing positive loop within developers' everyday work. So, a habit or context cue needs to be obvious. And within the normal working day of a developer, pushing code is an obvious cue. When they push that code, we have a routine. And generally, that routine that is engaged is resolving build failures. So you get feedback from the system on whether everything's passing, if there's been any problems created by the most recent push of code, and you resolve those build failures, all happening within the context of a merge request in GitLab. Then finally, we have that reward, and in GitLab, that satisfying capability of seeing those clean build checkboxes. So the more green checkboxes we see, the more satisfied we feel that we're building good code that counts. And this is a very typical way to form positive habits. If you want to construct positive habits in your life, you make an obvious cue with a routine that's easy to engage in and a satisfying reward at the end of each habit loop. Now, within atomic habits, there's something called habit stacking, which means that instead of having to establish a whole new loop, say looking in a different place, engaging with different information reports and consoles, and then having to understand that once you've resolved that, there may or may not be some sort of celebration of that. In GitLab, we simply stack vulnerability remediation management right into the merge request. So essentially, we're taking an important process or routine and simply taking advantage of an existing habit loop. So this is a very powerful way to motivate people to get into that vulnerability remediation habit loop. It also improves the joy of the process because now not only does this become more internalized, but software vulnerabilities are just seen as another defect, and they're rewarded with that clean build checkmark. It also causes things to be addressed early so developers don't have fire drills when they're coming up to a major release of the software. So that's a little bit of information about how GitLab uniquely connects with human habit psychology and specifically that vulnerability remediation habit being stacked onto an already existing build habit. So many of us are familiar with the developer's daily habit loop of pushing code, getting build feedback, looking at what needs changed, fixing that up, getting that satisfying feedback that the code is improving, becoming more functional, and also is quality code. But let's take a look at how this fits into the overall GitLab process and some important aspects of how that works. So GitLab has multiple stages through which development is tracked. These equate to the DevOps infinity loop of continuous improvement. And within GitLab, we have the capability to do work management. That work management is expressed in many different agile artifacts, which can also be used for other types of work management. But one of the key points is when we come down to the point at which a developer is going to start work, in GitLab, you create a merge request and a branch at the same time inside of GitLab so that all work is visible. When you do that, essentially you are pushing code to that branch right away because you're making a copy of the main branch, and the automated test and build capabilities start kicking in right away. One of the important parts here is creating an environment completely transparently without anyone's intervention. An environment's created. GitLab has this capability out of the box for any Kubernetes distribution. I have built it out for CloudFormation, and I'm working on building it out for serverless. This capability is really important because developers no longer have additional friction around getting environments. Now, the reason why an environment is important is if we're going to do all types of security scanning, so DAST, IAST, fuzzing, all the types that require an active copy of the application, well, then we need to make that available to developers at this point in their cycle of development. It's important to note, too, these are DevOps environments. DevOps environments are deployed where production environments are deployed. So each developer can have a production-like environment on just their feature branch. GitLab also supports dev environments, and these kind of work ahead of time before we hit a DevOps environment, but those work together. And also in GitLab, you can still have shared branches with shared pre-production environments as well. But GitLab is unique in that it pushes it all the way back to that developer feature branch timeframe. We then also have collaboration over all aspects of code, including security. And then developers have this remediation management that's basically a single pane of glass in that merge request. They can see everything that's going on with the code changes they're proposing making. As they get feedback and they push fixes, this environment is refreshed and it's rescanned so that they can get those green checkboxes on a vulnerability they might have just introduced minutes ago. When they get the final approvals that all their code is good to go in all aspects, including security, then they merge this branch and delete it. And when they do that merge delete, the environment's automatically cleaned up. So a lot of folks are like, hey, yeah, developers are never going to let us automatically delete their environments. But usually that's because it's so hard for a developer to get an environment. If simply creating a branch causes a new environment to come into existence, they're really okay with deleting them as soon as that code is merged because a new one is just a branch away. So just keep in mind that this aspect of transparently managing DevOps environments in the background is really fundamentally important to how GitLab manages vulnerabilities. So we also have some aspects of this that are extensible. Like we mentioned about this being an extensible platform, you can bring your own scanner extension. We tell you in our documentation how to make one. You can also build out your own DevOps environment extension, as I've done for CloudFormation. Another aspect of GitLab is that while all of what we've been talking about right now is all about developer productivity, developer joy, GitLab, because it focuses on value stream metrics, is really customer value focused. So at the next level up in the organization, we can keep everyone focused on generating customer value, even while also managing these important productivity metrics. So that's just an overview of how GitLab and some of its additional capabilities fit into making vulnerability remediation management just another defect that developers can work on. Here we have the venerable GitLab merge request view. Now, this view is what I call the single pane of glass for developers. It tells them a lot of information about what is going on with their software as they're building. Interestingly, a lot of this is interactive. It's not simply a log of things that have been done or things that could be done, and it keeps the developer in this context. So if we take a closer look at what's going on here, we have down here the vulnerabilities, and they're presented right here in the interface. These are interactive, so each of these blue links can be interacted with, and you can open up the vulnerability object. On there, developers can do things such as assert information like, I don't think I should have to work on this because, I don't know, it's a back-end component that we never exposed to the web, and this is a web vulnerability. Or we never use that bit of code that is vulnerable in this particular component. Whatever that claim is, they can make that, and that can be seen and reviewed by other team members as well as security. Also, they can immediately create a GitLab issue with all of the vulnerability object information on it. When you open up a vulnerability object, you have all the details of exactly what it is, a link to the CVE, and interestingly, a link to real-time training so that you can dig in and train more if you need to. By creating a GitLab issue from one of these vulnerabilities, you're able to then have the full collaborative capabilities of GitLab available to you. This is paired together with threshold-based approval rules. These two approval rules, license check and vulnerability check, are very special in that they only come into effect if a certain policy is violated. So in this case, the vulnerability check rule will only be triggered if the developer is trying to merge a high, medium, or unknown level vulnerability into the next branch, which is usually going to be a shared branch. And so this allows security to have a lightweight approach and only come in when necessary. I call this a Goldilocks single pane of glass. So we have just the right amount of information with just the right amount of tooling, with just the right amount of collaboration capability to pull in the right people at the right time, and just the right amount of oversight through these threshold-based rules. As we mentioned about GitLab being extensible, this is also extensible. So you can create your own approval rules as well as your own groups for those approval rules. So approval rules can be created by groups so that when you have changes in staffing, you can make sure that someone from the appropriate group is called in and that everyone can work together to lighten the load. Also, down here, when you bring your own scanner extension, as we mentioned earlier, you can also get it to show up right here in these vulnerability dashboards here. So that's just the concept of GitLab's merge request view. If we take a little bit deeper dive into these threshold-based rules, you can see here that I'm able to specify specific scanners, including custom scanners. I'm able to specify a threshold of how many, a count of how many of certain vulnerability levels are allowed. So we can also identify what level of vulnerability is allowed and whether they're newly detected or previously in the code. So generally in GitLab, you want to get the developer focused on newly detected things that they've accidentally introduced in their code. And then we can define that approval rule. So this is a really cool capability in GitLab that allows you to really narrow down on the lightest possible weight governance, but make sure that governance is indeed there. So that was a lot. Let's summarize what is going on here. In the book Atomic Habits, James Clear says, environment is the invisible hand that shapes human behavior. And really, when you think of an environment, it's got very rich context. So when you're in an environment, there's a lot of cues and clues about what exactly situation you are in. And so if we think about environment that way, we can think about the merge request as an environment. What's going on in GitLab when a developer is trying to manage their vulnerabilities inside of a merge request is that within their everyday habit loop that they're always working in for code changes they made moments ago. So this is for recent stuff that they've changed. Only newly introduced vulnerabilities are immediately visible and directly associated to that individual. So they know that, oh, I made this particular vulnerability. I should probably address it. They have a semi-private remediation opportunity. So unlike scanning on shared branches where every vulnerability that comes up is concerning and there's a lot of thought and exposure, when we have vulnerabilities in feature branches, we're not really that concerned about them because it's not code that's going anywhere yet. So if a developer upgrades an open source component and then it gets flagged as a critical vulnerability because that version is vulnerable, and in the MR it says, by the way, if you upgrade to this new version, you're going to no longer be vulnerable. They're most likely going to upgrade that version, rebuild the code, and see what happens. If they have their unit tests in place, they'll know whether their code continues to work. So that remediation opportunity is semi-private and allows them to work and eliminate vulnerabilities at their normal pace of fixing code defects. They also have potentially auto remediations and on-demand training available to them in that context. We don't have auto remediations for everything, but it is an aspect of how GitLab allows developers to remediate things when it's a simple fix, such as upgrading an open source component. We also have per vulnerability full collaboration capabilities. So the ability to understand and have the entire team pitch in if necessary when a developer is struggling with some sort of fix or a security problem that they're not familiar with. Notice that in this way, remediation management defaults to the developer. Now, when we say remediation management, we mean who's responsible to make sure vulnerabilities get resolved. Developers always have to be the ones who actually code the fixes because there's a high chance that they'll cause some sort of issue with the code. And so developers really are the only ones who can apply remediations to their code and successfully keep the code working. But who manages that process and makes sure that gets done? This causes that to shift to the developer, and in a good way. Developers like to create high quality code. They are craftspeople who love high quality craftsmanship. And so they're more than happy to engage at this time with this information and this kind of empowering tool set. Now, on the traditional remediation management, almost all of these particular things are opposite. So visibility is late and delayed, responsibility might be diffuse, alerting is broad and panic oriented. So all of this causes remediation to be a lot harder. The collaboration is especially challenging with emails and meetings and documents and just trying to figure out if something's already been fixed. In this case, remediation management generally defaults to the security staff. And this is because they're the ones who run those reports and also then take responsibility to move through the organization to make sure that these things get handled. To be quite clear, GitLab has traditional remediation management built in, and you do need that so that your development teams also get interested in paying down tech debt in the case of security. Maybe some medium vulnerabilities they can get rid of, or other ways that they can improve the software security profile. So GitLab still has traditional remediation management, but it's pushing remediation management all the way to an empowered shift left that causes GitLab to be truly different in this area. I want to spend just a little bit of time talking about how GitLab's approach to this causes you to be able to accelerate DevSecOps maturity as an organization. So, this small idea of making sure that we have alignment with human habits bubbles up to very big benefits in terms of DevSecOps maturity as an entire organization. We encourage you to have DevSecOps maturity be something that you plan. The approach of kind of getting started on something is really helpful for a lot of things. But in the case of DevSecOps maturity, it's going to be important to plan it because there's literally no end to the amount of investment you could make in this area because it's a risk versus cost trade off. So when you need to make those investments, it's best to have some sort of idea what you believe DevSecOps maturity is as an organization so that you can plan when you hope to get there and you can make the right resource investments. When this doesn't happen, customers start to run into a lot of challenges as we'll see here. Generally, for most organizations, DevSecOps maturity means more teams doing more types of scanning more often for more lines of code for more of the languages in their growing total code base. So it generally means doing all of these things more and earlier in order to ensure that we're eliminating things as soon as possible, or really eliminating them before they ever get into the code in the first place. Many customers who start down the road of kind of piecemealing this together end up running into some typical challenges. The complexity of their tool set that they've put together to do this, the implementation costs for various tools. As you grow, you generally need to implement more tools. And if there's more back-end systems for these tools, those costs start to rise. Remediation management hires. So we touched on that aspect of who's going to be responsible for remediation management. Because if it's not the developer, generally, as you get better at this, you need more people to manage remediation. And so this is one of the challenges that can really grow to be a problem. Also, developer learning curve. If you get a new developer in, some organizations use a metric of, how long till a developer does the first build on their own. I've heard organizations that target less than a day, like literally hours from a new hire in development, being able to build the entire system. It gives you a broad measure of really how complicated is our process. So that developer learning curve is an important aspect of friction against DevSecOps maturity. Then having to manage and maintain anything that you've bought, or even if it's free, if you've stood up subsystems to perform parts of this process, the long-term management of the ops of that is also potentially substantial. You then have the code-based growth. Code that's generating money for companies is generally growing as they add new customer valuable features. Usage-based pricing is another thing that customers sometimes don't see coming. I heard of one organization that tried out a security product in a proof of concept. They got a bill for $30K that year. But then when they went to scale it to all of the scanning that they would need in a year, the price tag was north of $1 million. So it's important to watch those usage-based schemes that charge you for the amount of code you scan. In a way, they start to penalize you for getting better and tighter and sooner in this loop of finding vulnerabilities. And then anytime your processes aren't automated, it's a real challenge. And the way you can tell when your processes aren't automated is when the process of getting something done is very belabored external to the system. So whenever we're managing remediation of vulnerabilities, if that involves a lot of spreadsheets, and emails, and meetings, consoles and concepts and reports, that's when you can see that you don't have an automated process. Now, all of these are stumbling blocks and are painful, but they also represent a total cost of ownership curve that is hockey sticking. Many organizations, when they don't pre-plan DevSecOps maturity, they head on down this road, and at a certain point, they're told they must stop due to escalating costs, whether it's hires, whether it's software licenses, or operations. So just keep in mind that we tend to see that this concept of roadblocks is also causing a lot of cost in the system. So with GitLab, we feel that doing it yourself DevSecOps can result in compounding penalties for getting better, getting more mature. So make sure that whatever you're doing now, you kind of plot it out and understand where this curve's going before you get too far down the road. Now, by contrast, GitLab's curve is flat. And the reason for that is you're charged by the number of developers. Usually your developers are a predictable metric back to the value generating activities of your organization. If you've got some old code bases, you don't change much, but you need to keep them secure, and new code bases that you're keeping secure, well, the number of developers working on that is a reasonable measure of productive work that's going on. So I always like to ask customers, when you look at the big shiny factory that is GitLab DevSecOps and you're comparing it to some sort of, new MVPs of securing your software, you really want to take a look at how are those MVPs going to scale to get you to where you want to be for DevSecOps maturity. We've been talking a lot about the development process, but I just want to give a quick head nod to GitOps. So GitLab has been doing GitOps for traditional infrastructure for a long time. And as this slide is building out, you will see a bunch of purple boxes. Each of these purple boxes represents ways of gaining control over the aspect of software development to make sure that it's high quality. The purple boxes, though, apply not only to getting your code ready for integration and review, which is our green branch here on the screen, it also can apply to one or more DevOps environments, which is the orange branch you see on the screen. So keep in mind that GitLab has a lot of additional protections, both those that exist in traditional Git, and then down here below the orange line, a lot of additional controls that allow you to make sure that deployments are going to the right places when you want them, and with the right approvals and right controls. So just keep that in mind, that all of the things that we do with code when we're trying to get it ready and be really robust and mission critical, all those same capabilities are available for deployments within GitLab. So, what we've been talking about today is transforming secure development to be a business as usual habit. We talked about how getting inside of that developer habit loop is really important. And we took a little segue into GitLab's platform first orientation. You want an extensible platform that you build out on. Also, context and timing is crucial. Doing these things at the time when a developer is expecting to, in other words, when all the parts are out on the bench, is super important. And that means we got to have dynamic security scanning very early in the process before the developer merges to a shared branch. We want transparent responsibility because that motivates all of us to understand that, hey, if we want top value craftsmanship, we need to make sure that our code is clean, not only in terms of functionality, but also in terms of security. Collaboration and real-time learning is an important aspect of this. Developers do not want to become security experts. They want to build code. And so when we have these runtime and real-time capabilities for them to be able to tap into others, tap into learning when it matters, that really helps them out in making sure they take the time to resolve vulnerabilities as they need to. And then finally, those only when necessary approvals reduce the friction and noise in the whole process, because the oversight that we need from security and other organizations can be done just when it's needed and not as a constant source of alerting fatigue where folks stop looking at things because there's so many alerts coming from the system. So all of this works together and aligns with human habit formation so that GitLab can be that platform that allows your developers to be experiencing joy and engaging voluntarily in remediating security vulnerabilities. Just wanted to do a call out that if you need help with GitLab and how it works with AWS in any regard, including what we've talked about here in terms of security, we have a special sales alias for that. And you can reach me at any of these social handles out on the internet. Thanks very much for your time. And I hope that you understand now a little bit better about how GitLab is lining up to be your DevSecOps platform.